Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic series and parallel connected sources. So first, what is a source? So source is a device which converts mechanical energy, chemical or thermal or some form of energy into an electrical energy. In other words, the source is an active network element meant for generating electrical energy. The various types of sources available in the electrical network are voltage and the current source. So sources are classified into voltage and current sources. Voltage sources in turn is of two types. They are ideal voltage source and practical voltage source. Similarly, current sources is of two types, ideal current source and the practical current source. First, we can see what is this voltage source. Voltage source is a device that generates exact output voltage which in theory does not change regardless of the load current. Ideal voltage sources will have zero internal resistance. Practically, an ideal voltage source cannot be obtained. Sources having some amount of internal resistance are known as a practical voltage source. Due to this internal resistance, voltage drop takes place and it causes a terminal voltage to reduce. The smaller is the internal resistance R of a voltage source, the more closer to an ideal source. The symbolic representation of a ideal and the practical source is shown in the figure. And next, what is this current source? Current source is an electronic circuit that delivers or absorbs an electric current which is independent of voltage across it. An ideal current source is a current source that supplies a constant current to a circuit despite any changes in the circuit. An ideal current source provides us constant current with a 100% efficiency. This is a symbolic representation of a ideal and the practical current sources. And next is this is the graphical representation of an ideal current source. The current remains constant even if there is a change in the voltage or time in hours. And this is a graphical representation of a practical current sources. So here there will be a decrease in the current I whenever there is a change in the voltage. Whenever there is an increase in the voltage, there will be a decrease in the current. This comes under the practical current source. And next is the ideal voltage source. In case of ideal voltage source, even if there is a change in the current or even if there is a change in the load, the voltage remains constant. Whereas in case of a practical voltage source, even whenever there is a change in the current or time, there will be a change in the voltage. So what happens when connecting a voltage source together? So ideal voltage source can be connected together in both parallel or series, the same as for any circuit element. Series voltage add together while parallel voltage have a same value. And next is a voltage source in parallel. This ideal voltage source can be connected in parallel provided they are of same voltage value. Next, voltage source in series can be connected in two configurations. They are a series aiding configuration, series opposing configuration. In series aiding configuration, the two voltages are added to get the resultant voltage. Whereas in case of series opposing configuration, the two voltages are subtracted to get the resultant voltage. And next is the current sources in series. Current sources are not allowed to be connected together in series, either of the same values or one with the different values. Series connected current sources adds an unknown factor into a circuit analysis, which is not good. Another reason why series connected current sources are not allowed for circuit analysis technique is that they may not supply the same current in the same direction. And next, connecting two or more current sources in parallel is equivalent to one current source whose total output current is given as an algebraic addition of an individual source currents. Current sources in parallel can be connected in two ways. First one is parallel aiding configuration and second one is parallel opposing configuration. In parallel aiding, two currents are added to get the resultant current, whereas in parallel opposing, two currents are subtracted to get the resultant voltage. And next is a parallel aiding configuration. This is a diagram that indicates a parallel aiding configuration and the diagram indicates a parallel opposing configuration. So that's all about the different way of different types of the sources. Initially we have seen about what is a source, and we have seen what are all the types of sources, and we have seen about the voltage source, what is a voltage source and what are the types of a voltage source. We have seen about the ideal voltage source and we have seen about the practical voltage source. Next we have seen what is a current source, and we have seen what is this what are the types of current sources. Under that we have seen this ideal current source, and second one is a practical current source, and we have seen a graphical representation for the ideal current sources and practical current sources, ideal voltage source and the practical current source. And next we have seen what happens when connecting a voltage sources together, and we have seen what is this voltage source in parallel and what are the different way of connecting the voltage sources in series. And next we have seen what is the current sources in series. Why current sources in series connection is not allowed, what are the reason behind it. And we have seen what is the current source in parallel, and we have seen how to connect the current sources in parallel. There are two configurations are involved, where parallel aiding and parallel opposing. That's all about the voltage and the current sources. Thank you.